Okay, here is our question. And it is reading, it is a very wide question, but it is just a matter of interpretation. The question is reading, a body of mass 8 kilograms lies on a rough plane inclined at 20 degrees, not degrees Celsius, at 20 degrees to the horizontal. The moment you learn how to sketch for these situations, I want us to first sketch for these situations, then maybe I want us to first interpret the question by sketching. We have said that a body of mass 8 kilograms lies on a rough plane. This is my rough plane. The body, rather the plane is inclined at 20 degrees, but this is the body lying on that mass, and the body rather lying on the plane, and the body is of 8 kilograms, meaning that the weight is 8g. Of course, you have to put the components. So this is 8g cos 20 degrees, and this is 8g sine 20 degrees. Right? They are telling us that a force of 8 newtons is applied parallel to the plane. The force applied, the force of 8 newtons applied parallel to the plane is just sufficient to prevent the body from sliding. This is my normal reaction. The force applied is enough to prevent the body from sliding. What does it mean? It means that the body was already sliding. Okay? The force of 8 newtons applied is enough or is sufficient to prevent the body from sliding. It means that if the body was sliding, then the force of 8 newtons is applied on that body and is sufficient enough to prevent it from sliding. So the force is moving up, but because the body was sliding already, it is being moved up, meaning initially it was sliding, and therefore our frictional force is also pointing upwards. Is my interpretation clear?
You repeat it because you are breaking.
Is my interpretation clear?
You repeat it because you are breaking on that part of the 8 newtons.
They have said that the force of 8 newtons applied is just sufficient to prevent the body from sliding. It means that the frictional force acts up the plane. Because if the body was sliding down, if the body was being prevented from sliding down, it means that the frictional force was applying upwards, isn't it? But the force that is preventing it from sliding down must be pointing upwards also. So the frictional force and the force itself are pointing upwards. Is that clear?
Yes.
So for this case, you can resolve and you get the value of a coefficient of friction. We shall see. That is the case. Then another case, they are saying that find the coefficient, you've gotten it. With the body at the top of the plane, the applied force was removed. When the body reached the top of the plane, of course, it was being prevented from sliding down, meaning it kept moving. After reaching here, the force, the 8 newton was removed. So we don't have a pulling force now. We no longer have that pulling force because it has been removed. So this is still 8g, this is still 20 for that case. We shall have our normal reaction and our components. We shall have 8g sine 20 degrees, shall have normal reaction. No, this is cos, sorry, cos, this is cos 20, and this is 8g sine 20 degrees. Now, If up, they have said that after the body reaching up, okay, the applied force, after the body reaching the top of the plane, the applied force was removed. So we no longer have the force. So they need the time taken. But it means that the applied force was the one removed, but the frictional force is there. So we only have one force, and that is the frictional force. So still by resolving here, you can get conditions that take you to an answer. My interpretation is clear.
Yes.
So for the first part, you can resolve and get the value of mu. And for the second part, you can resolve still and you get all the things needed. Now, let me take you to the calculation, how we go about it. So I will begin with when the force applied was just sufficient to prevent the body from sliding down. We sketch it like this. So if you resolve along the plane, resolving forces along the plane, you realize that you'll be having along the plane, you have 8 plus F equaling to 8G sine 20. Okay, but of course, before I call it equation 1, this is 8 plus mu r is equals to 8G, the sine of 20 degrees. But perpendicular to the plane, you can really see that our r is 8G, the cosine of 20. When you substitute, you'll have your 8 plus mu times 8G cos 20 is equals to 8G sine 20, isn't it? So we're interested in mu. We are interested in mu. Am I clear?
Yes.
So it means that 8 mu G cos 20 degrees is the same as 8G sine 20 degrees minus 8. And this one will give you the value of mu as 8G sine 20 minus 8 over, you will divide by 8G cos 20. Where G is, we have 9.8, so 8 times 9.8 sine 20 minus 8 over 8 times 9.8 cos 20. So when you work out this, you're going to come up with a coefficient of friction as 0.255. Is it clear? Then they have said that after the body reaching up the plane, my body has reached up the plane, the force was removed. We have already seen that condition. When the force was removed, the applied force, here of course we still have 8G, and this is 8G cos 20 degrees, and this is 8G sine 20 degrees. This is the normal reaction. The applied force was removed, but we still have the frictional force. So still by looking at this, by resolving, now, here you can see that the only force, okay, because when the other force was removed, after the body reaching up the plane, the force was removed. Meaning when the force is removed, now the body is sliding down. The body will be coming back down. So the frictional force will be acting upwards still. Okay? As the body would be moving down, because the other force moving it up was removed, this force pulled this body until it reached up. After reaching up, this force was removed. When the 8 Newton force was removed, now the body is sliding down. When the body is sliding down, the inclined plane being rough, the frictional force will be acting upwards. Is that okay?
It is okay.
Now, you realize that the only force responsible for motion is 8g sine 20. Now, for this case, we have what we call the resultant force. We shall look for the resultant force because now the only force responsible for motion is 8g sine 20. Don't tell me that 8g sine 20 is equals to frictional force. No, it must be counterbalancing some other force. So now the only force responsible is 8g. Meaning that if I'm to get the resultant force for this, the resultant force is going to be equal to 8g sine 20, because the body is moving down, but is being opposed by frictional force. That is how we get the resultant force. But this is the same as 8g sine 20 degrees minus mu r. But when you resolve perpendicularly, r is equals to 8g cos 20, implying that the resultant force F, let me say resultant force is going to be equal to 8g sine 20 degrees minus 8 mu g cos 20. But by Newton's second law of motion, we know that force is equals to ma. Because the question needs find the time taken. They have given us the length. So if they have given us the length, we can get the acceleration and we substitute in any equation of motion that has time. We can get the answer. So F is equals to ma, meaning that the resultant force where F is, we shall put all this. Mass, we have it as 8 kilograms, acceleration, we can get it. So we shall have that ma, which is 8, mass is 8 times a, which is acceleration, is equals to force, which is the resultant force, 8g sine 20 minus 8 mu g cos 20 degrees. We can get acceleration. So our acceleration is 8g, which is 8 times 9.8 sine 20 minus 8 times mu, which is 0.255 times 9.8 cos 20 degrees over 8. And this one will give you your acceleration as 1 meter per second squared. After getting acceleration, they need the time taken, but we are given the length, that is our S, the length as 2 meters. So remember, the body slides from rest at the top of the plane. When it reaches up, it is at rest now before sliding down, meaning that the initial velocity is 0, acceleration is 1, time we don't know it, but we have distance S, which is 2 meters. So that's why we use the equation of motion. S is equals to ut plus a half at squared. substitute. Let me complete it from here. Are you getting me well?
Yes.
Our S is 2 meters is equals to U, which is 0 times T. The whole of this is 0. So it is 0 plus a half times acceleration 1 times T squared. So this is 2 is equals to T squared over 2. So this is 4. When you cross multiply, 4 is equals to T squared. And therefore T is equals to 2 seconds. Is it clear?
Yes.
Let's do some other example. A body of mass 2 kilograms lies on a rough plane which is inclined at 30 degrees. Is inclined at 30 degrees. To the horizontal. A force of 20 newtons is applied to the body parallel and up the plane. Parallel and up the plane. If the body accelerates up the plane, at 1.5 meters per second square, find a coefficient of friction. Between the body and the plane. Okay. A body of mass 2 kilograms. So if the body is of mass 2 kilograms, sketch is inclined at, the plane is inclined at 30. The body is of mass 2 kilograms, meaning the weight is 2g. Has got components 2g or 30 degrees. Normal reaction. And this is 2g sine 30 degrees. They are saying that a force of 20 newtons is applied to the body parallel and up the plane. To the body, force 20 newtons. So it means that if the force is applied up, the frictional force will be moving the body where? Downwards. So if we are given such, and they have given us acceleration as 1.5, they want us to find a coefficient of friction. Now, if they have given you the acceleration, then I think we need to get the resultant force. The resultant force will be 20 minus, because this is the pulling force. This is the pulling force, since the body is to move up. So the pulling force must be greater than this. So the resultant force is 20 minus the summation of these two. So we shall say that this, when you have motion, a question involving motion, getting a resultant force is the one that will take you to the answer. So the resultant force is equal to 20 minus 2g so this is of course 20 minus 2g sin 30, then of course minus mu r. But r, when you resolve perpendicularly, r is equals to 2g cos 30. When you look at this, r is equals to 2g cos 30. What does it imply? When you substitute it there, it means that you'll have your resultant force as 20 minus 2g sin 30 minus 2 mu g cos 30. 2 mu g cos 30. But the resultant force F is equals to mass times acceleration. So the mass is 2 times acceleration is equals to 20 minus 2g sin 30 minus 2 mu g cos 30. And here you can easily get the value. So can bring this acceleration was given. We shall have 2 times acceleration, which is 1.5, plus 2g sin 30 will come this side, minus 20. This one should be equal to of course, I've substituted direct and brought these ones this side. So here I will be left with negative 2 mu g cos 30. So what you'll get here, of course, will be negative something, because you'll see you're subtracting minus 20. So you get some simplified thing. So you'll have, you're going to have 2 times 1.5. You can substitute, then plus 2 times g, which is 9.8. Then sin 30 minus 20 over negative 2 times g, which is 9.8. Then cos 30. This one will give you the value of mu. Can put on the calculator until you see a value of mu as 0.424. Is that okay?
Yes.
Okay, since I believe in more examples, let's do another one. A parcel of mass 1 kilogram is placed on a rough plane which is inclined at to the horizontal. Coefficient of friction between the parcel and the plane is 0.25. Find a force that must be applied on the parcel in a direction parallel to the plane so that A the parcel is just prevented from sliding down the plane B, so that the parcel is just on the point of moving up the plane and C, the parcel moves up the plane with acceleration of 1.5 meters per second. When they give you acceleration, the moment they put something to do with motion, that is when you look for the resultant force. But for the first one and the second one, you just resolve the forces. So I'm going to first show you the sketches for A, B, and C. For A, when the parcel is just prevented from sliding down. I want to first show you sketches and you see. Of course, let my force be P. Let the force that prevents the body from sliding down the plane, let it be P. That should be your introduction. Angle of inclination is 30 degrees. Maybe this is my capacitor. It can be anything, the way you present it. It is of weight. It is of mass 1 kilogram, meaning that the weight is 1 G, which is G. I'll have G equals 30. And then I'll have G sin 30. Normal reaction. They are saying that I find a force that must be applied in the direction prior to the plane that would prevent the parcel from just sliding down, meaning it was sliding down. So to prevent it from sliding down. So initially the frictional force was upward. So one can say mu R, or one can say just mu, right? Or one can rather, no, one can say F, or one can say mu R here. Then since the body, the force is being applied to prevent the body from sliding down, means that force is P. But when the body is just being prevented from sliding down the plane, I have said that you can use resolution of forces perpendicular to the plane and parallel to the plane. So when you resolve forces along the plane, we are going to be having P plus mu R equals to this. We shall have P plus mu R is equals to G sin 30. So meaning that my P plus our mu was 0.25, the coefficient of friction, 0.25 R is equals to 8, rather is equals to G sin 30. But you know that when you resolve perpendicular to the plane, you have your R as G cos 30. So if R is equals to G cos 30, it implies that our P plus 0.25 G cos 30 is equals to G sin 30, meaning that your P is going to be equaling to G sin 30 minus 0.25 G cos 30. So this one can give you the force in newtons. You will substitute for G as 9.8. That is when the parcel is just being prevented from sliding down. Is that okay?
Yes.
But on part B, they're saying the parcel is just on the point of moving up the plane. The parcel is on the point, is just on the point of moving up the plane. So if the plane is inclined at 30, and this is my parcel, this is its weight G. These are its components, G cos 30. This is another component, G sin 30 R. If it is just on the point of moving up the plane, that means that now the frictional force is acting downwards, and the force pulling it to move just up the plane is P. Is that okay?
Yes.
So now for this case, it means that our P, when you resolve along the plane, our P is going to be equal to 0.25 R, because F is equals to mu R, which mu was given as 0.25. So 0.25 r plus g to the sine of 30. But you know r is g cos 30. So p along when you resolve perpendicular, you be stepwise. When you resolve perpendicular, resolving perpendicular to the plane, p is equals to 25. R will be g cos 30 plus g sine 30. Here, after computing, I get 2.778. If it gives you 4 decimal places, prefer 4 decimal places. Okay, record 4 decimal places. And for this case, you get your P as 7.02 Newton. Is that okay?
Yes.
But part C is totally different from them because the sketch is the same as this of party B, because they're saying the person moves up the plane with acceleration this. So since we are now in motion, it means that you are going to change your approach. And how? It means that now we shall bring in the resultant force issue, right? So part C, I'm having the body, which is my person. Inclined, the plane is inclined at 30. This was G. So now the body is moving up the plane, meaning that the friction is down. Now, but for this case, we need the resultant force because we are talking about motion. So the resultant force is going to be P. The force moving the body up must be greater than this. So G sine 30 plus F. So this is the same as P minus G sine 30 minus mu R. But when you resolve perpendicularly, R is equals to G cos 30. Drawing that the resultant force, which is the same as mass times acceleration, mass is 1 times acceleration, which was 1.5. So we shall have 1 times 1.5, that is MA, is equal to P minus G sine 30 minus the value of mu. The value of mu was 0.25, then R, which is G cos 30. So you can get your P this side as 1.5 plus G sine 30. I've taken all this on this side, then plus 0.25 G cos 30 degrees. Solving this will give you a value of P as 8.25 Newton. Is that okay?
Yes.
So basically, that is what we have to do. Can I give you some numbers to try?
Yes.
So let me give you like 3 numbers to try, and then we see. Right. Are you ready to write?
Yes.
A box of mass 6 kilograms is placed on a rough plane.
It's set on a plane.
Is placed on a rough plane, which is inclined at 45 degrees to the horizontal. which is inclined at 45 degrees to the horizontal. Full stop, continuation. The coefficient of friction between the box and the plane, the coefficient of friction between the box and the plane is 0.5. Is 0.5. Find the parallel force. Find the parallel force to the plane that must be applied to the box. That must be applied to the box so that the box in column Roman 1, so that the box is just prevented from sliding down the plane. Two is just on the point of moving up the plane. 3 moves up the plane with an acceleration of 2√2 meters per second square. The first one, check and see if you get 20.789 Newton. The second one, check and see if you get 62.367 Newton. The third one, check and see if you get 74.367 Newton. Let me give you another one, possibly the final one. Are you ready?
Yes.
A body
Yes.
a body of mass 5 kilograms is initially at rest. At the bottom of a rough inclined plane. At the bottom of a rough inclined plane of length 60 meters. Of length 60 meters. Continuation. The plane is inclined. The plane is inclined at 30 degrees to the horizontal. It's inclined at 30 degrees to the horizontal. Are you there?
Yes.
And the coefficient of friction between the body and the plane is 0.5. The coefficient of friction between the body and the plane is 0.5. Continuation after full stop. A constant parallel force. A constant parallel force a constant parallel force of 15 newtons is applied to the body, is applied to the body causing it to accelerate up the plane. Causing it to accelerate up the plane. Causing it to accelerate up the up the plane. Full stop. Find the time taken for the body to reach the top. Find the time taken for the body to reach the top and its speed on arrival. And its speed on arrival. And its speed on arrival. Answer? T is equals to 11.84 seconds. And V is equals to 10.14 meters per second. So check and see if you come up with those answers. That one will maybe bring us to the end of friction. We shall see what to do later on there. I wish you all the best. Do the best.